Well, there's a few news stories that I thought were interesting. So Google has an interesting story from the threat analysis group talking about the commercial surveillance industry. And I run into this all the time. I have students who are being stalked and harassed by somebody that's constantly on their computer, constantly messing with their social media accounts. And it can ruin people's lives. And years ago, we would say these people are just making it up or confused, but now it's entirely possible, and it doesn't take millionaires to buy this stuff. There is stalkerware people can put on your machines to track you down. There's a bunch of commercial companies making this stuff, and a lot of people are using it to harass people and drive them nuts. And there's quite a lot of it that happens. Mozilla, in a related story, Mozilla will now charge you $100 a year, and they will clean your data out of these data brokers that sell your data, which is another form of spying on you. This is the most common type. They put cookies on your machine, and they track every app on your phone, and they collect all this data, and they just sell it to anybody that wants to buy it. Mostly companies for targeted ads, but the police buy it, and the NSA, and the FBI, and in principle, other people could buy it. And there's just a lot of this going on. A lot of privacy intrusions are really hurting people. Taylor Swift just sold her plane because a student was posting the location of her plane everywhere. It's the same guy who did it to Elon Musk. It's public data, but most people don't know how to get it. And he made like a Twitter bot that will constantly tweet every time her plane lands anywhere. And then she has crazed stalkers that stalk her, just what Elon Musk said. And so she went so far as to sell her plane. And she's probably going to lease a plane so it keeps changing to make it harder to track. So, you know, people that think people are stalking you everywhere, often it is true these days. It's not impossible at all. And once they get in your system, it's hard to get rid of them. Let's see if there's anybody to get past the ads. All right. And I'm checking for comments here. All right, good evening. All right, so a government official, intelligence chiefs have said, Christopher Wray, the FBI director, said that not only are the Chinese hacking our critical infrastructure, but they've been in there for 5 years. This is very likely. As I've been talking about in the OT security class, our stuff is very vulnerable, and nation-state actors, especially the Chinese, have a long history of doing this. They will hack in and they will not do any harm. They will just put in a remote control bot so they can continue to examine everything you're doing and just wait there for some future time when it may be desirable to turn off things or mess with things. They were in Google for a long time before they got caught. This is what intelligence agencies do. They establish a permanent stealthy presence to spy on you. You don't know they're there, and they're just watching what you do, and they can do more damaging things if they want to at any time. There seems to be a great rising awareness of operational technology security, which is a real problem in America. It'll cost a lot of money to fix. Microsoft has something called PC Cleaner. Now, there's been an open source product called CCleaner around forever that a lot of people use to try to make their Windows machines run faster and clean off damage done by imperfect uninstallation. And now Microsoft has made their version, and they make big promises that it will improve your PC. So if anybody tries it, I'm not sure how well it works. I know a lot of my students like CCleaner, so I guess it has some value. Now, I've been talking today on Mastodon about tokenization. Tokenization is at the heart of large language models. And what happens is you take English sentences and you break them up into chunks which have meaning, which are sometimes words, sometimes part of a word. And then each one of those is represented as a mathematical number in a high-dimensional vector space, and the relationship between the tokens mirrors the relationship between words. So now, detecting the trend of English is just a matter of fitting a line through a high-dimensional space of data, and that's why all large language models are really doing nothing more than curve fitting. They're just finding the trend in your prompt and then extending it. To see what would logically come next, according to just a mathematical extension of the direction you started going in this high-dimensional space. And at the heart of it has been tokenization, but when I put it on there, one of my Mastodon followers, who's very good at this mathematical stuff, pointed me to this paper that just came out last month where somebody pointed out one problem with this tokenization is it only works for English. It wouldn't work for other languages. So these guys made a large language model without tokens. They just take the pattern of bytes and they use that as the measurement, and they predict the trend of the bytes. And they claim the end result is that it is faster and more efficient than tokenization. Now, one thing they do not report here is how accurate it is. There is a standard test, and there was a report recently of the most powerful large language model. In fact, let me find that. Yeah, SMOG 772B. This is what I wish they had done, which they did not do. There are different qualities of open source models, and there are benchmarks, just like for many other things. And here's some of the benchmarks. If I can ever dig through all the stupid ads. These benchmarks ask it a series of questions where they know the right answer, and they say humans will get it 90 to 100% right. And the best models are like 75 or 80. Well, now it's getting up towards 90, so the models are approaching the lower end of human capability to answer questions. And that would be my question about these tokenized models. Are they really as accurate, the non-tokenized models, as the tokenized models? But it's an interesting step forward, especially for non-English language. This would certainly be the thing to do. One thing I do not understand yet is how they get the relationship of all the tokens correct in this high-dimensional space. I don't think they have a human rating the difference between these words, and so they must be somehow doing it statistically, and I don't quite understand how they've accomplished that. Anyway, that's an interesting topic. And this, I thought it quite appropriate for this class. Another hole in Android, and it really is pretty severe. The way it works, there are these things called Apex modules in Android. These are pieces of code which run with high privileges in the Android operating system. And what happens is, the process whereby you develop these things involves first you sign them with a test private key that is known and in the public repositories. And then later, you're supposed to replace the signature with a signature from your own real private key. And what happens is, people don't complete the second step. So there are modules available that have code that runs with high privileges in Android, and that code is signed with a known public private key. So you can forge an update and it will accept it. So that's interesting, and it seems like kind of obvious how it would happen. So each vulnerable device had a privileged apex in common, and therefore you can attack it. So your attack scenario would be to trick you into installing an update. And anyway, it's interesting. It has to do with these Android internals, which we'll be talking more about as we go ahead. All right. And got a few minutes. Let me see if there are any other good ones here. There's an attack on BitLocker that got a lot of press, but I wasn't too impressed by it. Let me bring it up because people might have seen it. Yeah, you got a Raspberry Pi attack to attack BitLocker. The point is, if you're on the somewhat older hardware now where the Trusted Platform module is a separate chip, then you can, when you boot up the machine, if you don't have a pre-boot password set, then it takes the key from the Trusted Platform module and sends it over a bus to the CPU, which it uses to decrypt the hard drive, and all that happens before the user enters a password. So all you have to do is find that pin and listen on it, and he's able to find that pin and make a little device with a Raspberry Pi on a board that just automatically cracks it and finds the BitLocker key, which is just sent in plain text over a pin. But the problem is, this is, in my opinion, incorrectly configured BitLocker. You're supposed to configure BitLocker with a pre-boot password that you have to type in. That's what makes it secure. And then the lack of that password means that the key is never taken out of the Trusted Platform module. So, however, when I talked on Pulse Security Podcast about this, Travis said many people do deploy BitLocker this way for the convenience of their workers. And so that's, of course, the famous issue. Most security features are inconvenient, and it's difficult in your company culture to convince people to use them. Anyway, that's enough of the news. Let me stop that.